Welcome back. This is going to be section 3.6 in chapter 3. It will actually be the last section that we do for this chapter, and it's going to cover lines in the coordinate plane. So we're going to learn how to, well, probably not learn how, you probably know this already, how to graph lines and write their equations in slope or slope-intercept and point-slope form, which you have already. You did that back in your algebra course. We're also going to look at how we can classify lines as parallel, intersecting, or coinciding. And coinciding is just a special word for saying same line. Okay, we'll talk more about that as we get through this lesson. So some vocabulary, just two forms for writing the equation of a line. Okay, point-slope form and slope-intercept form. Most students tend to remember this one really well. This one they kind of forget sometimes. Okay. A little note here. Equations of lines can be written in lots of forms, but most of the time we'll use point slope and slope intercept, and they're actually equivalent to each other. And I'll explain that again as we get further in this lesson. But you also need to know that the slope of a vertical line is undefined, and for that reason, we probably won't be able to use point slope and slope intercept form to define an equation for a vertical line. Okay. This is a great table to help you remember the different forms of writing an equation. So let's get into it. The point slope form of a line is given by y minus y1 equals m times x minus x1. So the things you would be given to write an equation of a line in this form is you would know the slope right here, and you'd know the location of at least one point, okay, x1 and y1. And you would substitute those values in to give yourself the equation of a line, which would look like that. Okay, that defines the line. I can pick any point on that line and it'll make this equation true. Now the slope-intercept form of a line is written a little bit differently. It's y equals mx plus b. M again is our slope, which you would be given the slope or you could calculate it. And you would also know the y-intercept, which we call b. Okay, this is where it crosses the y-axis. So a quick little diagram of that. If I had something like this, this is the y-intercept or b. And we're going to talk a little bit more about that in just a second. Now again, like I said before, there's a couple of others here that we don't typically use one of these two forms for. So if I have a vertical line, and it's a vertical line, remember, is going to be crossing the x-axis. So you'll have an equation that says x equals an amount, or where it crosses the x-axis. So remember, it's a vertical line crossing the x-axis. A lot of times students think of this and they think, well, it should be y equals, because we attribute vertical with the y direction. Okay, it's actually written just a little bit different. We end up with the same problem sometimes on a horizontal line where we think it should be written as x equals something. Okay, so we reverse these a lot of times right here. But it really is written as y equals b. So it's saying that my horizontal line is going to cross my y-axis somewhere at some value of y, okay? And that would be that value that we're talking about. And a couple of examples of those are right here. And there's another form that we use actually to kind of get us to the point slope form. I don't like to use it as often. I just think it's a little extra, but we do have something called the 2-point form, and you'll see that in some books and some problems. And really the 2-point form is just another name for the point slope form. Okay, and all we've done in that form is we've written the slope, we've written it out in its formula, right? This is the slope formula right there. Okay, and it's helpful. It is a helpful form if you're given 2 points, because you're going to have to calculate the slope, because you probably won't be it probably won't be given to you. So that's why we have the 2-point form. Some things to watch out for. You may be given one form, like the point slope form, but you may be asked to rewrite it in the slope intercept form. Okay, so just make sure you're paying attention to the problem, whether it's on an ACT test, one of my tests, or maybe another math class. Pay attention to what form they're looking for and make sure you write it in that form. But you can always, if you're not given it a request, you can write it in slope intercept form. Okay, if you don't have anything, default to this. Here's another good point to remember. When you write the y-intercept, I'm just going to draw a quick little diagram here for you. If I'm doing the y-intercept, I want to write it as a coordinate. Okay, right here, this is the y direction. This is x. I'm going to have a 0, right, for the x coordinate, and then I'll have some value, we'll call it b, for where it is on the y axis. Now the opposite is true if I'm writing the x-intercept. So let's put this here, right? Y-intercept. And this is going to be the x-intercept, okay? So in this one, I'm going to have a value for x, right, where it crosses the x-axis. We'll call it a in this case. However, in the y direction, right, I'm going nowhere, so I need to put 0. So that's the way we'll write those coordinates. Okay, so anytime you have an intercept, you can always write it as a coordinate. So let's get in and practice some of these. So we need to write the equation of a line, and notice that we're given the slope already, and we're given a point. Okay, which leads me to think I need to write it in point slope form, and in fact, that's what it asks me to do. Okay, we can always go to from point slope to slope intercept, and we'll do a couple of those as well. So, point slope form, I'm going to go ahead and write it out. And I tell a lot of my students, especially tutoring students, to go ahead, write that on every single problem. Okay, yes, it takes you a little bit of time, but that time is useful because it slows your brain down, allows you to kind of think a little bit. Now I'm going to substitute what I have. Okay, and then I'm going to simplify, right? I can simplify this part right here, these two negatives right there. I know that two negatives multiplied, which is what this implies with this parenthesis, I can simplify it to plus. And now I have the equation of my line written in point slope form. All right, let's try another one. Now this time though, we want to write it in slope intercept form. So I'm going to have to do some work up front in order to do that because I'm not given the slope. Okay, so if I want to find the slope here, okay, I'm going to go ahead and start with the 2-point form, right? And here's my slope calculation right there that I need to calculate. I may even label this x1, y1, x2, and y2 because it helps me just remember, okay, where does all this stuff go? Because I have a lot of substituting to do. So let's do that next. Now once I have everything substituted, I'm going to do any calculations or simplifying. And here's what I end up with, right? Now for me, I'm willing to go ahead and accept something like this, but some of your teachers may say, you've got another simplification step in there, right? 1 times anything is just what it was, okay? So this is where I get my slope-intercept form right here, okay? Now there's no number given for slope, but you guys should know, right, that there's an imaginary, or I shouldn't say imaginary, a hidden 1 right in there, which represents my slope. Okay, let's try this one. Now this time I'm given the x and y intercepts, and they're asking me to put it in point slope form. Well, that's a little bit of a problem right now because I don't have points. But alas, I do have points. I just didn't realize that I need to write them in coordinate form. So my x-intercept, I'll rewrite as 3, 0, and my y-intercept, I'm going to rewrite as 0, -5. Then I'll substitute that in for my calculation for slope, right there. And I'm going to use 1 point. I'm going to use one of those points to put it into point-slope form. So in this case, I use my slope that I calculated right here. And I'm going to use this point, 3, 0. Okay? I could use 0, -5 also, okay, to represent the x1 and y1. So I'll put those in, and then I need to simplify my equation. Again, I would accept this, right, because for me, that's pretty much in point-slope form. But some of your teachers may ask you to simplify that, and instead of writing y minus 0, just write y. So here's a check it out problem, one I want you to do on your own. So go ahead and pause the video and write the equation of this line in slope-intercept form for me. I'll be back in just a second. Okay, let's see what you got. So in point-slope form, this is what we have. I have all the values I need, so I just need to substitute and then simplify. Now, this one actually simplifies, right? And I'd be okay if you left it like this, but it will actually simplify all the way down to this, which guess what that tells me? This tells me that I have a line that is just a vertical line with no slope. Okay, again, I've got another one I want you to try on your own, so go ahead and pause the video here and I'll be back. Okay, great. Now we're putting this one into point-slope form. Okay, so remember point-slope form means I need to calculate my slope first. So I'll do that calculation with my coordinates, and I get a slope of 0. Okay, that's fine. Let's keep working here. Now, point-slope form, right? Here's what we have. And again, you can use either of these points, either of these coordinates, right, to put in, right? But I can't mix them. Okay, so depending on which one you choose is fine. They will be slightly different. Okay, I chose 1, 2 for mine to use. You could have used -3, 2 also, and we'd still get the same answer. So when you simplify this, you're going to get y minus 2 equals 0, which could actually be further simplified into y equals 2. And again, we have a vertical line. Okay, let's move on. Now we've got the writing the equations of a line down. Let's move to graphing the lines if I'm given an equation. So here's my equation that I'm given, and it looks like it's in slope-intercept form. I have the slope, I have an intercept point. Now to graph this, what I'm going to do is pull out my slope and my y-intercept. And I'll start with the y-intercept. I'll go ahead and plot that first point. Okay, and if I plot that point, it's going to be at 0, 1, which is going to be right here. And the next thing I'll do is I'll use the slope. Now remember, slope, we also define it as rise over run. Rise meaning up or down, and then run will move to the right. Now I always teach my students to start with the top number, the rise. So that means we'll always either go up or go down, and then from that next point, we'll go to the right. So if I rise 1, go over 2, I should be somewhere over in here. And let's see if I can do that. Sure enough. Okay, I have a positively sloped line. Matches what I would expect from here. Let's try another one to graph. Now this one's written in point-slope form rather than slope-intercept form, which is fine. I know my slope, and I know a point. And again, I'm going to pull those out separately. Write them separately. I may just write them here. I may put m equals, and then put x1 and y1 equals, right? And just pull them right from there. -4, 3, -2. Now, I'm going to start with my point. Okay, that's going to be the starting place for me. So I'll locate that point and plot it, and then I'll use my slope. Now you'll notice I wrote my slope as a fraction, right? Because again, I want to have rise and run. So in this case, my rise is negative, so it means I'm going to go down. Okay, so -4, 3, -4, 3, make sure I'm doing that right. Okay, and look what I get. So I'm going down. Negative rise, do that first, and then run 1. Okay, now when you connect your dots, right, don't just connect the dots with a line. Go past when I'm doing the equation of a line. Okay. Okay, we're going to graph this one. Now look what I have. This says y is equal to -3. I'm going to go ahead and find real quick where y is equal to -3, and that's right here. It tells me that I have a horizontal line. Okay, a horizontal line right here. Okay. All right, so if I draw it, this is what I get. I'm going to let you do one here on your own. Go ahead and pause the video and we'll come back with an answer for you. All right, let's take a look at what you have. So pulling out the slope and the points. So I'll plot the first point, what you should have done, and then find your second point. 2/1, draw your line through the points, not just connecting them. So here's another one for you to graph. Go ahead and pause the video and work through this one and graph the line. Okay, so here's what you should have when you graph that line. Okay, compare it to what you have. Make any notes or questions, go back. If you didn't get it right, try and rework it and see what you get. If you get stuck, bring it in, let's talk about it. One more to graph. So go ahead and pause the video for a quick second, and then we'll come back. Okay, this is the line you should have gotten. Again, it should be a horizontal line at -4. All right, on this one, so a system of linear equations in 2 variables. Okay, it's going to represent 2 different lines. They could be either parallel, they could intersect, or they could coincide, meaning they're kind of on top of each other. It'd be the same line. So here's a diagram or a table that kind of defines all of that. So parallel lines are going to have the same slope, but they'll have a different y-intercept. If they're just intersecting lines, they have different slopes completely. And if they're coinciding or they're the same line, notice the slopes are the same and the y-intercepts are the same. So let's practice doing one of these. We need to find out, are these lines parallel, intersecting, or coinciding? So to figure this out, I notice that they have different slopes. So they do intersect. Okay, somewhere they're going to intersect. Let's try another one. So now these look a little bit different to me. Okay, so in order to try and get them similar so I can make some judgments or determinations, I need to really write this second equation in slope-intercept form, because I recognize this one already is written in slope-intercept form. Okay, so let's do that. So in order to get this into slope-intercept form, I need to divide everything in here by 6, right? Because I want to get 6 away from the y. And right now it's being multiplied. So if I divide that, I get this equation. And I quickly notice something when I compare their slopes. Look at this. Their slopes are the same, which means that the lines are parallel. Okay, another one. Same thing, we want to find out what kind of lines or what relationship they have. And again, I noticed that they're not written the same. So I have to find some way to make them the same. And it's probably best, again, to put them into slope-intercept form. So let's work on that first one. Okay, so I add the 4x to both sides. Right, I can show that here, plus 4x plus 4x. And then in the next step, I actually need to divide the 2 from both sides. Okay, from each term, right, needs to be divided by 2. And I end up with this, y equals 2x plus 8. Now in my other equation, I need to do some simplifying first with the distributive property. And then I can move this 10, this constant, to the right-hand side. Okay, now we're just using our algebra tools. Okay, so go back, use those algebra tools, okay, don't forget them, and look what happens. I have the same equation, which means that those lines coincide. Okay, good work. Lots of information in this lesson, lots of stuff to try and get through and to think about. I would advise you to go back, just kind of look back through your notes, maybe read through or listen to the lesson one more time so you make sure and get everything in your mind so you can retain it. I'm going to leave you with some practice problems to do, some practice examples that are in your notes packet. Go ahead and work through those, and if you can remember, ask me those answers when you come into class the next day.